Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 104th of physics, and in today's lecture we are going to discuss insulators and conductors. That is a very important topic as far as electricity is concerned. So let's get started. In the process of charging by friction, which we discussed in the previous lecture, we find that one category of materials can be electrified easily by rubbing with another. Such material include glass, silk, ebonite, hot rubber, and fur. For this category of materials, the electrons, which is negatively charged particle, are transferred from one material to another and remain on the surface. They do not move about with the material but are confined or localized at the region of rubbing. We call such material electrical insulators. On the other hand, there is another category of materials such as metals where the electrons do flow through them. For this category of materials, they are not easily electrified by rubbing with silk or fur unless they are well insulated first. We call such materials electrical conductors. Other electrical conductors include electrolytes and ionized gases, which contain positive and negative ions that are free to move, as you can see in these two figures. So electrons are fixed in the case of insulator, and it requires a lot of energy to remove the electrons from the effect of the nuclei. And in case of conductors, the electrons are not tightly bound to the nuclei and it can be removed easily. So this picture is giving you this scenario. In the figures, all the electrons of electrical insulators such as polythene, cellulose, acetate, perspex, ebonite, and glass are considered to be firmly bound to their nuclei. The removal or addition of the electron in one place does not cause electrons to flow. That is, the charge is confined or localized to the region where it was produced, for example by rubbing or place. For electrical conductor, as shown in the figures, such as metals, the outer or valence electrons are loosely bound and relatively free from individual atoms. That is, they are delocalized, although they are fairly strongly bound to the material as a whole. If such material gains electrons, the electrons can move about in them. Similarly, loss of electron by a conductor causes a redistribution of those left behind. Okay, let us turn our focus to another very important topic, and that is neutralizing charge insulators and conductors. To neutralize a charged body is to remove the excess charge from it. This process is also known as discharging. Dear learners, you must be aware of the term when we are charging our mobile. So it means that we are transferring excess of electrons to our mobile charger, and the mobile battery, and if we are using that mobile battery, then it means that we are removing excess charges of electrons. When all the excess of electrons are finished, then it means that the battery is discharged and you have to again charge it. Let us first concentrate on charged insulator. Just as it takes quite a bit of effort to charge an insulator, yes, this is the fact, because we cannot easily move the electrons from the effect of nuclei. Those electrons are tightly bound, such as a glass rod, by rubbing it with silk. It is also not easy to remove the excess charge from it. This is due to the fact that the excess charges on the insulator do not move easily. To discharge a charged insulator such as a glass rod quickly, one way is to heat the glass rod with a Bunsen flame. The intense heat causes the surrounding air of the glass rod to be ionized into positive ions and negative ions. These negative ions will neutralize the excess positive charges on the glass rod. All charged insulator also discharge slowly when left in moist condition. The water vapor in the air causes the excess charges on the insulator to leak away slowly. So that was the whole story about charge insulator. Remember that the charging and discharging of insulator is a very difficult process. In ordinary circumstances, you cannot do it. You have to provide either heat, and that is the first way of discharging the uh, insulator, and the second method is to put that insulator in the moisturizing conditions, but that is a slow method of the insulator to be discharged. Now let us talk about the charge conductors. If we want to neutralize a charge conductors, what we should do? For a charge conductor such as metal sphere with excess electrons, the electrons can be removed by earthing it. To earth a charge conductor is to provide a path for the electrons to flow away or towards the charge conductors and cause it to become electrically neutral. Dear learners, let me tell you here, whenever you are touching the desktop computer case, then you are electrified, because if there is no path available for the flow of excess of electron from the casing of the desktop computer and you touch it, then you are providing a path to those electrons to go to the earth, or positive charges are coming through your body to that electrons to neutralize it. So for that purpose, you have to provide a path of copper wire, then you will not be electrified and you will not be electrocuted. For a positively charged metal sphere, earthing it will cause the electron from the earth to flow towards the positively charged sphere and neutralize it, as shown in the figure. Here they are touching it, and these excess of electron will go to the earth through your body, and as a result that sphere will be uh, neutralized because this sphere is negatively charged and the earth is considered to be positively charged. So either the protons are coming towards the sphere through your hand and neutralizes those negative charges. Yesterday I told you that if a material is having the same number of electrons as well as protons, that material will be considered as the neutral particle. One thing you have to keep in mind here, that this stand must be insulating, otherwise the people will say that these electrons went to the earth through this material. So if it is an insulating stand, then this will not provide a path to the electrons to go to the earth. Only one possible path is your hand, through which either electrons will move towards the earth, or the protons are moving from the earth to the sphere. So for both figures, the purpose of the insulating stand is to prevent any electron flowing between the charged metal sphere and the earth. The human body is a relatively good conductor and therefore acts as a conducting path for the electrons. Remember these things in your mind. In this case, they are showing that either electrons are going, and in this case, as I told you, that protons are going to this, electrons are going to this positively charged. If it is negatively charged, these electrons will move towards the positive charge, which is earth. And if the sphere is positively charged, then electrons will come from the earth. Earth is a neutral body, so they are having electrons as well as protons. So earthing a positively charged metal will cause electrons to move from the earth towards the sphere. Now let us talk about charging conductors by induction. Induction simple means it spontaneously without any external help. Induction is the process of charging a conductor without any contact with the charging body. Now this is interesting. Without the charging body, how can we charge the conductors? The first topic was neutralizing. Now how we can charge it? Now the first of these cases is to charge two conductors with equal and opposite charges. They are negatively charged and positively charged. You can see A sphere is showing you the positive charges and B sphere is showing you negative charges. So let us see how can we charge these. The first step in this case is the two conductors metallic sphere on insulator stands are brought into contact with one another. Now first we are bringing these two sphere in contact with each other. So you can see that these two spheres are in contact with each other, and then here you can see that when you are bringing these two in contact with each other, what will happen? A negatively charged rod is then brought near to the sphere A. This causes the electrons from A to be repelled to the farthest sides. You can see that here the electrons are repelled to the farthest side of that negatively charged rod. Under this condition, sphere A alone will have excess positive charge due to electron loss, while B alone has excess negatively charged due to gain of electron. Okay, that was the second step. The third step is, with the negatively charged rod in place, the two spheres A and B are separated a distance apart using the insulating stand. So here you can see that we can do what we are having. We are separating it here, and when we are separating it from each other, then they will be charged. You can see that A and B are separated in the presence of inducing charge. So you can see that first here you can consider that there is a mix, positive and negative, negative and positive, and similarly when we brought these things in contact and brought a nearer a negatively charged rod, then positive charges will be attracted towards this negatively charged rod, and negative charges will move away because similar charges are repelling each other. So in this case they are repelled. So here you can see that these are now charged. Charge means that the positive and negative charges are separated. Positive charges will be on one sphere and only the negative charges will be on the other sphere. First they are mixed, positive and negative charges. So here you have to keep in mind, and there is a question from my side, that what it is written in yellow, what if you had taken the rod away before separating the two spheres? Then it could create problem and no charge of the sphere will take place. If you remove this negatively charged particle, negatively charged rod before separating the sphere, then they will become, the negative charge will attract positive charge and they will be mixed and neutralized. Once the negative charges are moved to one sphere, as in this case in B, and positive charges are to A, then separate it away from each other so they will get out from the effect of each other, then remove the negatively charged rod. So this was the method of charging two conductors with equal and opposite charges. Okay, there is a second way as well. Let us finish this topic today. So tomorrow we will discuss the electroscope. The second is to charge a single conductors by induction. Bring a charge rod, say positively charged, you can see that in the first figure, to the vicinity of conductor held by insulating stand. You can see this is insulating stand, and a positively charged rod is brought nearer to the negatively charged or the neutral. So you can see that the positive charge will attract the negatively charged and will repel to the farthest side this positively charged. This positively charged, because positive and positive charges are repelling each other. What we will do in the second step, the free electrons in the conductor will be drawn towards the end of the conductor nearer to the positively charged rod, leaving the other remote end to have excess positive charge. Note that the conductor is still electrically neutral despite the redistribution of free electrons, because the number of electrons and the number of protons are the same, so still they are neutral. Now in this third step we will do what? With the positively charged rod still in place, the conductor to be charged is earth. As you can see here, that we are earthing it. This can be done by touching the conductor with our body momentarily for a short interval of time. Being a relatively good conductor, our body will allow electron to flow to the conductors to neutralize the excess positive charge on the far side of the conductor. Note that now the conductor will carry an excess negative charge. It means that here if we are earthing it, so the negative charge will move through your body, so that it will do what? They will neutralize this positive charge and it will be vanished. Only negative charge will remain on the surface of this neutral, and whenever one type of charge is on the sphere, so it means that it is now charged. On removing the charging rod, the excess negative charge electron will redistribute on the surface of the conductor, attain electrostatic equilibrium. Now here also a question is there, that if that is written in the yellow, what would be the effect if you had removed the positively charged rod while the conductor is still earth? So it means that it will not produce the charging effect. If you remove the positively charged this one while still it is at the earth, so it means that the positive charges are there and then they will be redistributed on the surface of the sphere and it will be neutralized, not charged. So keep in mind, you don't have to remove this positively charged rod before removing the earth. Okay, that's it for today. Thank you very much for your time. Allah Hafiz.